Hey guys, welcome back to the channel. If it's your first time here, we go through math and physics tutorials, as well as how to improve the psychology of a student. In this video, we're going over analytic geometry and the characteristics of triangles. I'll be going through how to find the median, the altitude, the right bisector, as well as a review of parallel lines and perpendicular lines. This is part number 2 of a 3-part series related to analytic geometry. In these 3 videos, we're going through circles, triangles, and quadrilaterals. By the end of this video, you'll be able to find the medians, altitudes, and right bisectors, as well as the centroid, orthocenter, and circumcenter of triangles. If you guys find this video helpful, please like this video and subscribe to the channel to see more videos just like this. Stick around to the end of this video to learn how and why you should set up a study environment. Alright, so let's go over some of the basic characteristics that define a triangle. So a triangle obviously has 3 sides and 3 vertices, and all the angles in a triangle sum to 180 degrees. Now I want to talk about a bit more advanced stuff. So here we're going to have medians, altitudes, and right bisectors, as well as the points that correspond to each of these. So for medians it's a centroid, for altitudes it's an orthocenter, and for right bisectors it's a circumcenter. So a median is simply a line that connects the vertex of one point to the midpoint of the other side of the triangle. So if we were to show what a median is, we would take the midpoint from A to B of this triangle, so that's probably around here, and we draw a line from that midpoint to the opposite vertex. So the line would look like this. And that would be one median. But there are 3 medians in a triangle. So if we look at the other 2 medians, we have from A to C, the midpoint would probably be around there, and these are just rough estimates. And then we'd have the midpoint to point B, and that would be the second median. And finally, we would find the midpoint of line B and C, which would be right there, and the line from A to that midpoint. And that would be all 3 medians, and as you can see, they all intersect. And where they intersect, that's known as the centroid. And so centroids correspond to medians, and medians create the centroid. So now we're moving on to an altitude. And what an altitude is a perpendicular line from one side of the triangle to its vertex. So from line B and C, we're going to draw a perpendicular line all the way to vertex A. So right there, that would be one altitude, and that has a right angle right there. The next one would be, let's go from point C, and let's look at the line A and B. So let's find a line that's perpendicular to A and B, and also connects to point C. So somewhere probably around there would be a perpendicular line or an altitude from AB to vertex C. And finally, we'd have from point B a similar spot in the triangle just on that side, and that would form a right angle here. And this would be the third altitude of this triangle. So these triangles have 3 medians, 3 altitudes, and we'll see later that they also have 3 right bisectors. The point here at which all these connect or intersect is the point of the orthocenter. So altitudes correspond to orthocenters, and basically it's the 3 altitudes, the intersection point, that creates this orthocenter. And finally we have right bisectors, and right bisectors have kind of characteristics of medians as well as altitudes. So what we're going to do is we're going to find the midpoint of a side of a triangle. So we'll start with AC. So the midpoint is probably around there. And now we're just going to draw a perpendicular line from that point. It's not going to go through a vertex this time. So we're going to draw a line that's perpendicular to line AC at that point. So I'm going to say that's a perpendicular line right there. And that would be one of the right bisectors. And what a bisector really is saying, bi meaning 2, and it's intersecting a line, so it's splitting the line up, in this case line AC, into 2 equal lines, and that's why it's a bisector. So here, a right bisector, it's a right angle. It could also be called a perpendicular bisector, because this line is perpendicular to AC, or has a right angle between them. And we're also going to look at the other 2 right bisectors. So again, we would look at the midpoint between A and B, it's probably right there, and we're going to draw a perpendicular line from line AB. So probably around there. and this point right here is a right angle. And finally, midpoint from AC, this one's a little bit easier. We're going to draw it from a perpendicular line from the midpoint, and it goes through. So here would be the point of all three of them connecting. It's a little bit off just because it's all a rough estimate or a rough drawing, but this would be the circumcenter, this point here. So right bisectors form the, or I guess the three lines of a right bisector form the circumcenter of a triangle. So for problem 1, we're asked to find all three medians of this ABC triangle and find the centroid. So for medians, what the first step is to find the midpoint between all three lines. So I'm going to start with line AC, and I'm going to say the midpoint, I'll say mid right here, of AC is going to equal half the distance in the x direction of AC and half the distance in the y direction. There's a formula for this, but if you really understand what a midpoint is, it's half the distance of the line, and that would correspond to half the x distance and half the y distance. So here we look at A, we see an x distance of 2, or a point at 2. We're going to do 2 plus, and then over here is C, so that's negative 2, and then that divided by 2. And then that's the x point of this midpoint. And then we're going to get 2 for A plus 0 for C, and that's going to give us our y point. So our midpoint of AC is going to equal, well, 2 minus 2 is negative, or 0, so that's going to be 0 in the x direction. And that's going to be 2 plus 2, or sorry, plus 0 divided by 2 is 1. So that is going to be our midpoint, and it's probably around there. That's what we're saying our midpoint is. So I guess I'll do it in green. So now that we have the midpoint of line AC, we're looking to find the line or the equation which would end up being the median that connects the midpoint of AC to the vertex of B. So we're looking for the equation of that line right there. So to get the equation, I'll keep it in green. To get the equation of this line, we now have 2 points, the midpoint and point B, or the vertex that we're going to. So we can find the equation of the line. So if we look at the slope, it's going to equal the slope of, from midpoint of AC to B is going to be, well, B is negative 2 in the y direction, minus, and then our midpoint, well, that was 1, so minus 1, divided by 2, so this point here, this x direction of the point B, and then minus the x direction of our midpoint, which was 0. So our slope is going to be negative 2 minus 1, that's negative 3, divided by 2, so it's going to be negative 3 over 2. Now that we have the slope, what we can do is find the equation of the line. So we have y equals mx plus b, so in this case our m is negative 3 over 2x plus b. So now we can sub in one of these points. So I'll sub in, we can either sub in the b point or the midpoint of AC because this line is going through both. So I'm going to do midpoint of AC, so our y coordinate is 1. It's going to equal negative 3 over 2 times 0 plus b, because that's our x coordinate. So negative 3 times over 2 times 0 is just going to be 0, so our b is going to equal 1. So now we can write the median from from AC to point B is equal to, I guess I'll put it colon like this, y is equal to negative 3 over 2x plus 1. So that was one of our medians right there. So next we're going to find the median from the midpoint of AB to vertex C. So the midpoint of AB, or AB is probably around there, and we're gonna calculate that. So it's going to be half the x direction divided by 2, or sorry, x direction divided, and then half the y direction of this AB line. So the midpoint of AB is going to equal, well, point A is 2, and then it's going to be plus, well, point B is also 2 in the x direction, divided by 2. And then that is going to be, we have 2 in the y direction, minus 2. So 2 plus negative 2 divided by 2. That is going to give us a midpoint of AB to be at, well, 2 plus 2 is 4, divided by 2 is 2, and then we have 2 minus 2 over 2, so that's going to be 0. So that is our midpoint of AB. Now we're going to look at the line that connects the midpoint of AB to the vertex C. So this is the median we're trying to find. So here we're going to have our slope, and our slope is going to equal rise over run, just like last time. So we're going to say, okay, well, this point here is really just 2 comma 0. And so we're going to get our rise over run is going to be 0 minus 0 divided by, and then we're going to have 2 minus negative 2. So 2 minus negative 2. So here, our slope is actually 0. And it's the reason for this is because this is going to represent a horizontal line, or the connecting point between them is going to be horizontal. So what's going to happen is we can still go through our process. Y is equal to mx plus b, but now our m is 0. So we're going to have y is equal to 0 times x and then plus b. And if we sub in our points, well, this is just going to be 0 because 0 times anything is just going to be 0. So our y value, if we take our midpoint, is 0, and that's going to equal b. So the equation of the median line from AB to C is really just y is equal to 0. It's a horizontal line. So now we're going to go over our third and final median for this triangle. So we're finding the midpoint, or the median of the line that connects CB, the midpoint of CB, and vertex A. So here we're going to have the midpoint of BC is going to equal, so it's going to be 2 plus negative 2 divided by 2, and then comma, well, it's going to be 0, or I guess negative 2 plus 0 divided by 2. So here we get our midpoint of line BC to be 0, comma, negative 1. So now I'm going to plot that point on our triangle. That's right here, negative 1. So it's this point right in there. Okay, now that we have the midpoint of BC and vertex A, we can solve and get the equation of this median. So I'm going to find the slope between A and this midpoint. So I'm going to say that 2 minus negative 1 divided by, let's see, 2 minus negative 1, and then it's going to be 2 minus 0. So the slope is going to be 2 minus negative 1 is 3, and then divided by 2. Then we're going to have y is equal to 3 over 2x plus b. If I plug in this point here, I'm going to get negative 1 is equal to 3 over 2 times 0 plus b. So our b value is going to equal negative 1. And now we can write our entire equation of median, let's see, median BC to A, and it will equal y is equal to 3 over 2x minus 1. So that is the third and final median. Now that we found all three medians, we can look to see where they intersect, and that's going to represent the centroid, which was part B of this question. So I'm going to make it easy on myself, and I'm going to look at one of our equations, which is y is equal to 0. So I'm going to plug that in, that y equal to 0 for this value. So I'm going to say 0 is now equal to 3 over 2x minus 1. If I put it to this side, it's going to be 1 is equal to 3 over 2x. And then I'm going to draw it up here. X is equal to 2 over 3. So that's the x coordinate of this centroid. Now if we plug it back into one of these values, we're going to say, okay, well, let's plug it into this line right here. Y is equal to 3 over 2 multiplied by the x value, which is 2 over 3, all that minus 1. So this is going to equate to being 1. 1 minus 1 is 0. So the centroid, I'll write it over here, is located at 2 over 3, comma 0. And that would be roughly right there on this triangle. So now we're going to go over altitudes. And in this question, in problem number 2, it talks about, or asks us to find all three altitudes and then find the orthocenter. So remember that orthocenter corresponds to the altitudes intersection point. There's going to be 3 altitudes, just like there's 3 medians, just like there's 3 right bisectors for every triangle. and when they intersect, they form different points. In this case, it's the orthocenter. So, to get the altitude, what defines an altitude is a right angle or a perpendicular line from one of the sides of the triangle to its opposite vertex. So, we're going to find a line that is perpendicular to DE. So let's see, what would that be? Probably around there. And now this line is perpendicular, and we are looking for the equation of this line. So this is a good time to review what is a perpendicular line, like what's the definition of it. Well, what actually ends up happening is for parallel lines, the slope of the line will be the same, right? Because we're going to have a line like this and then a line like this. This slope here, or the rise over the run, for them to be parallel, the slopes have to be equal. They're never going to intersect. For perpendicular lines, the slope is actually the negative reciprocal of the other line. So in this case, what we're going to do is find the slope of line DE. So for DE, I'll do it in white. The slope is m is equal to, let's see, 5 minus 3 divided by 3 minus negative 4. So the slope is going to be 2 over, and that's 7. So the negative reciprocal of that, which would define a perpendicular line to that line, is going to equal, so I'll say perpendicular line is equal to negative, and then I'll say reciprocal. So here, the slope of the line we're trying to find, or the altitude, is really m is equal to negative 7 over 2. So I flip these around and then put a negative in front of it. And that's how you find the negative reciprocal. So now we have the slope of the line, and we also have a point it's connecting to. So again, we're going to use y is equal to mx plus b and plug in this point here. So this altitude is going to be y is equal to negative 7 over 2 x plus b. Plug this point in, negative 3 for the y value is negative 7 over 2 multiplied by 2 plus b. So we're going to get our b value, I'll write it here, is equal to, so negative 7 over 2 times 2, that's going to be negative 7. If we bring the 7 across, we're actually adding 7 to negative 3, so our b is going to be 4. So the altitude, and I'm going to say altitude of f is equal to, or is y is equal to negative 7 over 2x plus 4. So that's the first altitude. Now, for the second altitude, we're going to do this exact same process. So I'm going to take a line from E and make it perpendicular to, let's see, that is probably perpendicular to line DF. And then I'm going to find the slope of line DF. So I'm going to say m is equal to negative 3 minus 3 divided by 2 minus negative 4. So the slope is going to be negative 6 over, and then 2 minus negative 4 is just going to equal 6. So the slope is going to be negative 1. Now, for the negative reciprocal of this, because we want the line that's perpendicular to that line, we're going to say that the slope is, so I'm going to say perpendicular slope equals negative, or equals 1. And the reason for this is negative 1 is really just negative 1 over 1. To flip those around, all you're doing is putting a 1 on the top and a 1 on the bottom, so it's going to be the same magnitude of an answer, but we put that negative in there, and so it becomes positive 1. And so again, we're going to look at the point it connects to, which is E, and use that point to solve our equation. So we're going to get y is equal to x, because our n is 1, so we can just write x, plus b. If we sub in our point of 3, 5 for E, we're going to get 5 equal to 3 plus b. B is equal to 2. So our altitude of E is going to equal, y is equal to x plus 2. So finally, for our last altitude, we're going to get point D and bring it across to where it is perpendicular. It's probably right there. So that line is now perpendicular, and we're going to use line EF the points of EF, find that slope, get the negative reciprocal of that slope, and then plug it in to find our equation. So we have 3, 5 and 2, -3. I'm just going to write so I don't have to scroll up. Is 3, 5 and F is 2, -3. So our slope is going to equal, let's do 5 minus -3 divided by 5 minus -3 and then 3 minus 2. So M is going to equal, that's going to be 8 on top over, and that's going to be 1. So our slope, the negative reciprocal of this, will really be, perpendicular slope is going to equal -1/8, because I flip these around and I put a negative in front of it. Now we're going to use this negative slope, or this -1/8, and plug in our point of plug in our point of D, because that's the line we're going to in this case. So -4/3. So I'll say y is equal to -1/8 x plus b, and then we have the point -4, 3. So 3 is equal to -1/8 times -4, and that's going to be plus b. So we're going to get 3 is equal to, so these negatives are going to cancel out. We're going to get 4/8 plus b. B is going to equal 3 minus 4/8. This is really just, if I write it again, it's going to be 1/2. So our b, if we have kind of common fractions here, we're going to have 6/2 minus 1/2. So now we're going to get b is equal to 5/2. And this is our altitude of D, which will be y is equal to -1/8 x plus 5/2. Now that we've found all 3 altitudes, we can now find the orthocenter of this point. And we're going to use these equations of all 3 of these lines, set them equal to each other to find that point. So if we take this equation right here, the altitude of E, y is equal to x plus 2, I'm going to take this x plus 2 and sub it in for this y, because we're saying y is equal to that. So I can write x plus 2 is equal to -1/8 x plus 5/2. Now I'm going to put everything onto one side of the equation, all the x's and all the constants on the other side. So if we do that, what we're going to have is x plus 1/8 x is equal to 5/2 minus 2. Here, if we do common fractions again, this is 8/8x plus 1/8x is equal to, and then for here, this is going to be, that's 2/1 to get it to, so we're going to do 5/2 minus, and then if we multiply this by 2, it'll be 4/2. So now we're going to get 9/8x is equal to 1/2. And now if I solve for x, I'm going to get 8/18, which is really just 4/9. And that is our x-coordinate of our orthocenter. To get our y-coordinate, what we're going to do is plug it into this equation. So I'm going to use altitude of E, and I'm going to say y is equal to our x value, which is 4/9 plus 2. And then here we can have y is equal to 4/9 plus, and then we'll have 18/9. Y is equal to 22/9. And that will give us an orthocenter of 4/9, 22/9. And that would be the orthocenter of that triangle. Alright, so now for the final question, it's asking us to find the 3 right bisectors as well as the circumcenter. And that's the intersection point of all 3 right bisectors. So for a right bisector, it's kind of like a combination of the median and the altitude. What we're going to do is we're going to find the midpoint of a line. So we're going to find, let's call that the midpoint. And then we're going to draw a line that is perpendicular at that point. So we're not going to care about the vertex. We're only going to draw it like this. So we're going to draw, kind of go through there. That's probably perpendicular. So that line there, that's perpendicular, all those. So that would be the right bisector of GH. So why don't we find the right bisector of GH? So we're going to first find the midpoint of GH. So midpoint of GH is equal to, so it's going to be 8 plus 1 is 9 divided by 2. And then the y value will be 3 plus 1 divided by 2, so it's 4 divided by 2, so it's going to be 2. So now to find the slope of line GH, we'll do slope of GH, and that's going to equal, we'll do 3 minus 1 over, and then we'll do 8 minus 1. So it's going to equal 2 over 7. Now we want the negative reciprocal of that because we want the perpendicular slope to that line. So we will write the line of GH, or the right bisector of GH, is going to equal negative 7 over 2x plus b. And now we plug in our midpoint of line GH, or to get to the b value of this equation. The reason we plug in this midpoint is it's the only point we know that's on this line. So before we had another vertex point that we could use, or for the median we could use the vertex point and the midpoint. But here we only have the midpoint as our point to use. So we're going to plug in our midpoint of 2 is equal to negative 7 over 2 multiplied by 9 over 2 plus b. So that's going to be 2 is equal to negative 63 over 4 plus b. And if we solve for b, I'll do it over here. We'll get b is equal to, and I'm going to write the 2 as a 4 over 2 now to get to the common fractions. So 63 over 4 plus 4, 60, I'm going to have to do 8 over 4. So I'm basically just saying 2 is now 8 over 4. And so we get b is equal to 71 over 4. So now we have all the values that we need to write our equation. So we can say the right bisector, so RB of line GH, is y is equal to, negative 7 over 2x plus, and then we have 71 over 4. So now we can move on to the next right bisector. So I'm going to do HI. I'm going to find the midpoint of HI, and I'm going to draw a line that will make that point perpendicular. Probably like that. So for HI, we have 8, 3, and 4. So I'm going to write all of our points. Write it in white. H is 8, 3. I is 4, negative 2. So first we're going to find our midpoint of this line. So our midpoint of HI will equal, well, it's going to be 8 plus 4, which is 12, divided by 2. That's 6. And then it's going to be comma 3 plus negative 2. That's 1. Divided by 2 is 1/2. So that's our midpoint right there. Now we can find our slope. So I'll say slope of line HI is equal to, let's see, so it's going to be 3 minus negative 2 divided by 8 minus 4. So 3 minus negative 2, that's going to be 5 over 4. And again, we want the negative reciprocal of that because we want a perpendicular line to this line. So we're going to write y is equal to negative 4 over 5 x plus b. And to solve for b, we're now going to plug in our midpoint. So we're going to have 1/2 is equal to negative 4 over 5. And that's going to be multiplied by our midpoint value of x, which is 6, plus b. So we get 1/2 is equal to negative 24 over 5 plus b. If we solve for b, actually I'll do it up here. b is going to equal 1/2 plus 24 over 5. If we get a common denominator, this is going to be 5 over 10 plus, this will be 48 over 10. So here we're going to get 5 plus 48, that's going to be 53 over 10. We can now write our right bisector of line HI is y is equal to negative 4 over 5 x plus 53 over 10. And that will be our answer. Finally, we're going to get our last right bisector. So we're going to find the midpoint between GI, which is probably around there. I'm now going to draw my line at GI, or the midpoint of GI, to make that perpendicular. It's probably like that. And then that will be a right angle. So G is 1 and 1, and I is 4 and negative 2. So I'm going to write G is 1 and 1, and I is 4, negative 2. So to find the midpoint of line GI, so it's going to equal 1 plus 4 is 5 divided by 2, so it's 5 over 2 in the x direction, and then 1 plus negative 2, so that's going to be negative 1, it's going to be negative 1/2. So that's our midpoint. Now let's get our slope of line GI. And that is, let's do negative 2 minus 1 over 4 minus 1. That's going to be negative 3 over 3. And our slope of GI is equal to negative 1. But again, we want the negative reciprocal. So for 1, it's just 1 over 1. If you flip them around, it's still going to be 1. But it's going to be positive 1 because of the negative. So we're going to write our y is equal to 1x, so that's our slope, plus b. If we sub in our midpoint, we're going to get negative 1/2 is equal to 5 over 2 plus b. Now we solve for b, and we're going to get negative 1/2 minus 5 over 2. b is equal to, let's see, negative 6 over 2. b is equal to negative 3. So now we can write our right bisector of GI is y is equal to x minus 3. This line was a lot cleaner than the other lines. So now to get our circumcenter, or the intersection point of all three right bisectors, we're going to equate the lines that we've just found. So we have this x minus 3, and I'm going to use this y is equal to negative 4 over 5x plus 53 over 10. Plus 53 over 10. I'm now going to set this x minus 3 equal to this y value. So I'm going to say x minus 3 is equal to negative 4 over 5x plus 53 over 10. So if we bring all the x's to one side and the constants to the other side, we'll have x plus 4 over 5x is equal to 53 over 10 plus 3. So here, if we do 5 over 5x plus 4 over 5x, and then here we'll do 53 over 10 plus, well, if we get 30 on top, then that'll be a common denominator. We can now do 9 over 5x is equal to 83 over 10. And if we solve for x, it's going to be kind of a messy number, but 83 over 5, or times 5, and then it's going to be 10 divided by, or multiplied by 9. So that will be, let's see, 53 over 5, or sorry, 83 times 5 is 415, and 10, so 10 times 9 is 90. So our x is going to be approximately 415 divided by 90, or 415 is approximately 4.611. Now, if we use our y value, or calculate our y value, we can write y is equal to 4.611 minus 3, and y is going to be approximately equal to 4.611 minus 3, 1.611. So we have our circumcenter center to be at 4.611, comma 1.611. And that would be our final answer. We found all three right bisectors, and the intersection point equaled the circumcenter, which is what we were asked to find. Alright, so now let's talk about a study environment and why you need one. As humans, we're very good at associating various activities to the environment that we're in. For instance, our room and our bed is the environment, and the activity is sleeping. You might find it harder to sleep in a new place, and that's because your brain has not associated this new environment with that activity of sleeping. The same thing happens when you study. If you study in an environment that's only set for studying, your brain will quickly associate the two and make it easier for you to focus longer and have more effective and efficient study time. This is why something like a library is very effective. So I know most of us study in our room, and that's the place where we sleep, We watch movies, we surf the internet, we browse social media. So now our brain is associating all these different activities with the same environment. So now, when you sit down to study in that same environment, it's much easier to procrastinate and lose your focus because your brain's associating this environment with surfing the internet, browsing social media, or sleeping. The fix for this is to have objects in your room that you only use for studying. A good object would be a lamp. Take a lamp in your house and only turn it on whenever you start studying. Don't use it for anything else. It's never on when you're on social media, when you're going to sleep, or when you're watching TV. It's only on when you're studying. Now, when you turn the lamp on, this is now kind of a new environment for studying, and your brain will associate that environment for focused study. A research study done by the University of Hawaii actually did this exact experiment. They gave students a lamp, and they told them to only use this lamp when studying. The students who did this were 1 grade point higher on their average than the students who didn't. That's like going from a C, or a 75% average, to a B, or an 85% average, all from just turning on a lamp. So start with a lamp and try this out and see if you can focus longer and have more effective study time when this lamp is on. Thank you for taking the time to watch this video. If you guys like this content, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. I make a ton of content to help in math and physics, as well as improve the confidence and psychology of students. If you have a specific topic you want me to cover, let me know in the comments down below. Thanks again, and I'll see you guys in the next video.